Let me begin recording. Here we go.
Yes, that's a good. Yeah, sorry. Make sure you're recording.
Yes, reporting on. So this is the flight readiness review for the Tufts University rocketry team.
No, I'm doing a checklist as well at the same time, so I'm not I'm not ignoring you.
Okay, lovely. Fantastic. So we want to start with which section? Booster?
Start the booster and work your way up to the nose cone just as a whole. I'm looking particularly at the construction. I haven't seen a lot of your photos, so I'm not too concerned. Just want to get a good view.
Sounds good. Okay. Brett, can you turn your mic on and camera on, please?
Sorry.
Cool.
Wait, why don't you just keep your mic on?
Because I'll be further away. All right. So is your audio up on that?
I can hear. Yeah.
There we go. All right. So starting from the booster, this is the one we've flown in the past 2 flights.
Yep.
As you remember, we have a combination of through-the-wall fin construction and external fiberglass tip-to-tip layups. So this is
Yep.
3/16 inch fiberglass sheet for the root. It goes through the body tube, and there's an assembly with 3 centering rings and a fiberglass motor mount tube. That was all epoxied together, aligned properly, fitted inside the body tube, and then we did 4 external tip-to-tip layups. These are in a 0-45-0 configuration with 4 layers each.
Cool.
We also have our second updated feature here, which we're working on. We just have the layups left to do, and then integration of the bulkhead. So
It's always
this
good
one
to have a backup.
is, it has slightly thinner fins and slightly smaller epoxy fillets. So we went with 0.5 inch radius instead of the 1.5 inch radius on the flight vehicle. This is to just improve our weight characteristics, and we'll be testing them. So make sure everything.
Okay.
How does that sound so far, Ben?
Yeah, good. So you got a fresh plate there on your retainer.
Yes. So
How's that mounted?
okay. Yeah, we should probably all right, turn the volume down there, and if you can turn the volume up on my computer. Brad, can you still hear me?
Yep. You muted the phone again.
Okay, it's gonna
There we
have
go.
to mute that. Sorry about that. All right.
All good.
We're using an Aeropack RA98 motor retainer, commercial off the shelf, but it bolts directly onto our thrust plate, which is 3/8 inch thick aluminum, carefully machined, and it has these portions that go up inside about this far in the body tube. Those are all epoxied together. There's grooves turned into that thrust plate assembly, so that it's able to adhere properly to the inside of the body tube. We made sure to rough that up and to rough up the inside of the body tube as well.
Cool.
And then we just drilled the 12 attachment holes directly into the thrust plate and mounted the motor on top with, we did use different screws than the ones provided, but it's the same exact size. Of 832, number 832. And then we load the motor in, put the cap on.
Yep.
And it just tightens on, and that's that.
Yeah, perfect. And the tip to tip, what surface prep did you do?
Yes, so surface prep we sanded first with 80 grit sandpaper, then with 220. We cleaned with lint-free wipes and isopropyl alcohol, and then we were ready to do. We did pre-preg. So we cut out the shapes and then put the epoxy onto the fiberglass, and then laid that up, fixed any spots that were drier, and then proceeded with next layers.
Yeah,
I don't know if
perfect.
you want to talk about that more in a bit, but that's good. Yeah.
Cool. And your do you have the rail buttons there? The or whatever you're using? Sorry, I can't remember.
Oh, sorry, 1 second. Volume issues. Turn the volume down on here and turn the volume up on there. No, because then it gets picked up.
think you're on mute again.
Can you speak quickly?
Hello. Did you want me to talk?
Yes, that's a lot better. Sorry about that.
Sorry.
Can you hear us okay?
Yeah, that's fine.
Okay, fantastic.
Yeah, cool.
Carry on.
Yeah, can you show me the rail buttons and talk through the positioning?
So we're not.
They're on
the
the
underside.
here.
Yep.
So the aft rail button is the one that has to take all the weight of the entire booster, and that's drilled directly into the thrust plate. So
Oh,
when
wow.
we're making, we position it and then just drill the 1032 hole. There's a slight washer standoff so that we can get past the slightly increased diameter of the body tube there because of
Yeah.
the external fillet, external layup. And then the forward rail button, so I'm coming around to here. Thank you, Nick. Forward rail button is mounted directly into the aft airframe bulkhead, which is also a 3/8 inch thick disc of aluminum. And so this is mounted all the way into the aluminum directly with a 1032 bolt.
Cool. How did you calculate where to put it?
So we focus primarily for this for the forward rail button or for the aft rail button.
Yep, for the forward. Sorry.
For the forward rail button, we place the bulkhead first and then place the rail button on the bulkhead. It is it's close to the center of gravity. We prioritize bulkhead positioning over rail button positioning because we wanted to have more solid rail button attachment, more so than we wanted to have exact positioning of the rail button. But we tried to size it as close as possible so that it is close to the center of gravity.
Okay, great. Awesome.
Nice.
Cool. Right. So yeah, just moving moving along the tube, you can just show me the coupler now, I guess. So
What do you want to
move
come to this?
into it. Cool, just show me around. And you've got using shear pins.
Yes. So shear pins.
How many?
Cisco.
Cisco.
I don't know.
Recover,
There's
please.
shear pins somewhere.
No, we don't. We're not using shear pins. We can pull it apart.
Yeah, there's no shear pins in there right now.
On the
No,
booster,
not now. But yeah, just yeah.
on the booster section, we're
how-
using. Oh, I'm sorry.
You're right. Yeah, just how many shear pins? How you got to calculate that? If you can just walk through
Yeah.
that.
So we're using 440 nylon shear pins on the booster, which is the drogue section, and 440 nylon on the main, which is the forward section.
Yeah.
We calculated that based off of the pressurized, the volume of the pressurized compartment and the force to break the 440 nylon shear pins. We're using to break 440, we're using compressed gas, which is we're using 35 for main and 35 grams of CO2 and 23 for drogue.
Cool.
Any other questions about that?
And your test results, I've seen the video, but for the purposes of this
So,
just-
we ground tested black powder successfully with 6 grams. We tested 5.45 and upsized to 6 for the main, and we tested 2.26 for the no 2.4 something as well for the drogue. I might have those numbers, but we upsized to 3 for the drogue grams of black powder. And then we also ground tested the compressed gas. We ground tested successfully 23 grams of CO2 on the booster and 35 on the main as well. On the booster section, we actually tested with 6 shear pins because we had to upsize the amount of CO2 used. Because the canister size for the specific Raptor system that we had, it was either above or below what I calculated. So we upsized the number of shear pins to sort of lessen the blast. But then on the ground testing, we saw that the blast wasn't as big as we were hoping. So we downsized again to 4 shear pins.
Okay, cool. And you're comfortable based on your test that you'll get successful?
Yes, we had a
Separation?
successful
Yeah.
separation in every ground and flight test.
Yeah, cool. Awesome. Cool. So that's enough on that section. This we'll come back to we'll do a full eBay review later. So if you can just move forward into the nose cone coupler and just show me just around that area.
Yeah, so the bulkhead
Nose
for,
cone. Yeah.
sorry,
Yeah, continue.
the bulkhead that attaches the harness for the main parachute is similar to the aft airframe bulkhead. It's also a 3/8 inch disc of aluminum with a U-bolt mounted in there. I actually neglected to mention this on the booster, but for both, we have a ring of fiberglass, coupler tube fiberglass that's been epoxied on the inner side, so on the side facing the parachutes, so that during parachute deployment, if we have a particularly hard deployment, the load is not going entirely through these screws on the outside of the airframe, but it's also like there's something stopping the bulkhead from pulling out.
Gotcha. Yeah.
As for the nose cone is temporarily under repair because it came down a little bit hard in the last test flight and there's a crack. We're planning on filling that with epoxy, doing a slight internal layup, thinner external layup, and sand that down. The nose cone is attached with 632 screws from here. These go all the way through into the coupler. The holes in the coupler are tapped. And then it's not mounted in here today, but the nose cone GPS assembly, Nick, do you want to bring that over? The nose cone GPS assembly, pardon the duct tape, it's just for wire management, mounts
Yep.
into the nose cone, and that holds our completely backup, separate, redundant GPS tracking system.
Cool.
Yeah.
Right. And main deployment. So is
Just
that
Yes, so the main deployment is from the forward section. Did you want to see the harness and take it apart now?
we'll do that next. So I
Okay.
just wanted to understand what
Right.
your
So-
configuration first.
So the main will deploy forward section at about 1200 feet.
Yep.
And then the booster is the drogue section at G, of course.
Yeah. What's the size of your main?
96 inch Cyrus Ultra.
Cool. And based on your design and testing, you're comfortable with the speed it comes down?
Yes.
Yeah, the velocity. Yeah. Sorry, use the right terminology. Cool. Awesome. It looked pretty good in your test flight video. I was wondering if you took a little bit of damage. It looked a little bit hard, but that'll explain the crack in the nose.
Yeah.
And yeah, you found just the one little bit of barbed wire in the place by the looks of it.
We did. The second test flight came down a bit hard because the booster section, the harness attaching the drogue to the booster got caught on the pilot that was attached to the drogue or to the deploy bag that was attached to the main, and then pulled
Right.
the main down. So those successful deployments, successful filling of the main, but just by chance, we're sort of troubleshooting that by decreasing the length of the harness from the avionics bay to the drogue, as our mentor Sam suggested. And also not having a deploy bag as well, so that there's less harness to actually get caught on any other section of the harness.
Nice. Cool. All right. Next, I'd like to see the separations. So if you can simulate those, starting with the booster side, the aft end.
All right.
So,
Ben, can we have you help out too?
Yeah.
And whoever's free from Izzy, Sean, or Brett, just so you can hold it.
essentially, I want to see it. I want to see it separate, and we'll then have a look at your lines and your joins.
Sounds good. All right, ready?
Perfect. Yep. Cool. That's enough. Yep. Cool. So
Alright, step back a bit so that you can see the lines coming in folded.
So,
yeah.
oh, this was supposed to be a bit like briefed with, in
Yep,
flight
that's
with the
fine.
standard state.
Yeah.
So this will be 10 feet from the avionics bay to the drogue, which is still in drogue chute, which is 36-inch ballistic chute.
Yep.
This is 35 feet from drogue to booster. And then we
Okay.
have cord protection, and because these cords are nylon, not Kevlar, we have cord protection because our backup energetic is black powder. And then we also have a Kevlar to protect the entire harness system.
Yep. Okay. You're comfortable with the strength of those lines?
Yes.
Did you do any pissing on them?
Yes, we did. So we did an instron testing specifically on if so Ari, if you'll show them the
Yep.
connection point here, I sewed a large 6-inch connection in the loop of each harness, and we
Okay.
tested this on an instron machine, and it withstood. The instron actually failed at 1,000 something, but that was because of a friction with the clamp, and it actually tore the harness apart before the actual loop came apart. So this has been tested thoroughly.
Yep. Cool. Awesome. And your mounting points? Can you just show me on the bulkhead side?
Yeah, on the left.
So we
the
have
D-link and the-
a quick link that's rated up to 3,000 pounds of shock force,
Yep.
with a U-bolt that's rated, I think, to 6,000 pounds of shock force.
Yep. Cool. Awesome. And can you just quickly show me down the tube? I'm not expecting to see it, but can I see the mounting at the other end if you can? Oh yeah, I can actually see it. Yep. Perfect.
Nice.
Cool. Awesome. All right. I'm happy with that. So if you show me the main deployment now.
All right.
Alright, you can look at the box for me, please.
So,
It's very good. Okay, and Izzy, or Sean, can you guys please help? So Nick, you hold the admin. So,
yep. Nice.
alright, someone place the blocks under here, please. Thank you. Okay.
So we have again 10 feet attached to the main from the outside. Main 96-inch Cyrus Ultra, and then 40 feet from the main to the forward section.
Right. Cool. Okay. And show me the joints, the mounting points.
So we have
each
quick link
side.
again, and then also I didn't mention on both parachutes, there's the swivel link and quick link attached
Gotcha.
to the shock
Yep.
links.
Yep. Cool. Yep. Perfect. Awesome. Alrighty. That all looks good to me. Next, I'd like to review the eBay. In particular, I'm looking at the construction of wiring, your switches, your choice in switches, battery retention. So if you can run me through all that.
Okay. Wiring isn't completely finalized yet because we had to switch it between the last flight and the last test flight and this flight because we had found some errors in it and we're replacing some things.
Yeah.
Well, I'll go over where it will go once it's finished.
Nick wants to switch back.
Oh, it's we should pull it out. We can pull it out anyway. Yeah, it's
This way
so
it's
it's secured. Bulkheads are secured by wing nuts on this side. And those are tightened down, and the other side has 2 lock nuts on either side. I'll show you in a second.
Oh yeah. Yeah, perfect.
Wait, buddy.
Oh, you can get up. She one wing is still in. Okay, I got it. So pull up. The other side has lock nuts on both sides here, so this bulkhead is static on these. All threads. The eBay itself is mounted on, it has bolts attached to all threads with rubber watchers to prevent vibrations.
Oh, yeah.
Just take it on.
It's dual RC3.
Yes, so dual RC3, there will be two SREDs on here.
Yep.
They're still
I'm
under
not too
testing.
worried about those. Can you
Yep.
show me how they'll be mounted? They're just on those mount points, are they?
Oh.
Yeah,
Yeah.
cool.
Right here. They're still under testing, which is why they're not in there.
Yeah, that's fine.
So the batteries will go on the other side like this.
Yeah.
We're still in the process of replacing these battery mounts since they broke on our last flight because
We had some, on the last flight, we had some minor delamination of the battery case. We've changed the print orientation, increased the infill, and thickened some of the structures where we saw failure in the last time. So we're pretty confident that they'll withstand flight this time. Having looked at some of the literature on shear stress of 3D printed PLA, we're pretty confident that the new design will be more than sufficient for both launch and a hard landing, so to speak.
Yes. And type of batteries you're using?
we're using 18950 wide poly batteries with 2500 milliamp. We're using gonna be 6 total. Gonna be 1 battery for each of the RRT3s, 1 battery for each of our SREDs, and then we're gonna have cameras mounted directly in here. And these are gonna have their own separate batteries.
Cool.
That are gonna be inside the FA. These cameras are gonna be controlled by the SRAD computers with a switch. So the 2 of the batteries will be going through this board. Yeah, they're connected with these connectors here. They're the lock JST ones. I don't think that's the name of them.
Yeah, that's the ones. Yeah.
And so they'll be connected to those to the batteries themselves, because the batteries themselves have those in one of their sides directly connected. That's how they came out of the box. So we use the same connectors to not mess with the actual batteries themselves.
Okay.
So the switching wiring. So the switches are right here. They're all key switches. We use key switches to prevent accidental turning on and off of the rocket, in flight and on ground. There's be 1 for each of the boards. It's hard to really see because it's tight, but they're connected through white wires. All of the switch wiring is gonna be white. It's going around. They come down around here, back into these switches here. They're going to be routed through, as you can see, the same way that these wires are routed like this. They're routed through these holes here to keep them less tangled and keep them more organized. And yes, these here, this RC3 is going to be replaced actually because, as you can see, it broke in one of the flights, so we're going to replace. We have a new one so we don't have to use these. But these wires coming from, to keep them organized, we're going to have the wire. Each of the firing wires color coded her board, so we know which one's going to which. And so this is the backup or the primary. This is the primary will have, or the primary as it's set up now will have the yellow orange wires going down here. It's routed out here through down there, and then back through there, connected up here. We have these screw terminals at each the side, so we can to make it easier to attach the igniters. There'll be 2 more for the SRADs when they're ready. And did I miss anything? Oh, there'll also be more wires coming out the back for, we have the go over here, there's thermocouples on the motor itself, and so there'll be more wires. If you can see, it's hard to see because they're all laid out.
Yeah, they're taped to the side of the motor mount tube right now, but they'll pass through the bulkhead.
And they're gonna pass, we're gonna to tape them to the.
I can see them.
Right? We're gonna tie them to the harnesses and put them through this is the bottom, right? Put them through here. There's gonna be 8 wires coming through using I2C connections. They're going to our SRAD computers. And the other internal sensors is a outside temperature sensor, which is going to be mounted right here. And those wires are going to go to one of the boards through forward wires as well.
How are you detaching the thermocouples?
So there's gonna be there's a thermocouple amp that's gonna be on the bottom bulkhead there. For
Yep.
each of them. That's gonna directly read them. That's going to send. Yeah, that's gonna send
Yep.
data over I2C data. What's the name of it? Data I2C is a data send
Data protocol.
data protocol. I just blanked the name. A data protocol. Use I2C data protocol to send them back up to the SRI computers.
What are you
Um,
doing with the wiring during separation?
So we're going to just make the wires long enough and put them onto the harness and protect them the same way as we protect the
Okay.
there and just
Cool.
attach them to the wires. Test the
Cool.
wires that go all the way around.
You're gonna run them down your lines.
Yes.
Yeah, okay.
Cool. I had another question there. I can't remember what it was. Anyway, your wiring, with the clips, are you doing any further retention, particularly on the battery connections?
For these clips,
Yes.
uh,
Have you thought of any further
we have not.
No.
But there's we have
do you
not.
consider like just a simple bit of electrical tape around them, just
Yeah, that we could do that easily.
just as an extra? I've seen those clips come apart. That's all.
Yeah, we have not experienced any of that.
Did the so on the top RC3 there, has the terminal block, did you say the terminal block came off, or did it?
It came off and we resoldered it, but we're gonna replace it with a normal RRC3 anyway. We've another one, we just haven't gotten around to replacing this one yet.
Cool. Okay.
Oh, so we're gonna replace that for the actual site.
Have you considered retention on the terminal blocks? Is there anything you have you made thought of anything on that?
The terminal blocks have been historically fine for us, so we have not. And they have not failed us on, we've used one of these on quite a few flights and it hasn't failed us yet.
Okay.
When it's on them to work. So we have not, so we think that these terminal blocks should be fine for retention.
Brody and Daniel, but you guys have thought about the clear coating as protection. Does that also?
That's for
structural?
clear coating's for the, for the SR boards.
Okay.
Oh,
Could
for the
that be
boards.
applied to the RC3 as well?
He's talking about not clear coating, he's talking about what's the name of it? Conformal coating, which might end up doing to the SR boards to protect them, if we can find a safe way to do it. Yes. Any other questions?
Cool. So I'm just going through my checklist to make sure I got everything. I think that's it for the eBay. So I'm just looking down. Your charge wells, they're 3D printed.
These are metal charge wells.
Are they? Cool. So I couldn't tell what the material was.
And
So
there's
And then we hang on that reference here.
Steve the Raptors.
Yes.
These are for the black powder. And we have for the CO2 is another system we have.
Yep.
We have these Raptor systems
Yeah, cool.
and ejection systems. So there's the energetics is primary, it's the CO2, and then we back up, we just have one black powder well. We have
Yeah.
redundant because on the first flight, we tested both redundant or primary and backup, but we're just using one black powder charge well.
Yeah, cool. All right. Okay, we can probably move on from there. Let's have a look at your payload. Sorry, I can't remember the details of your payload. Essentially, I just want to look at fit, any chance of entanglement, etc. on the line. So if you can just show me through how your payload will be attached, deployed, etc.
Right. So yeah, we'll go over that in a second. Actually, Vanessa, do you want to go over the payload and the adapter first, and I'll just show how it fits in.
Yeah, sure. So
Yeah.
the payload is a 2U CubeSat that has some sensors in it and electronics in it in terms of
Yep.
what the payload is. And you can see here, this is a PLA prototype of what the integration piece is gonna be like.
Yep.
It's gonna be ABS. We're still printing out the ABS right now and getting more. But this is designed to like be really modular, right, and very accessible. No chance of entanglement. And then these pieces go up top here, and we're printing also the symmetrical second half right now, which is why we don't have them, but there's probably going to be a circular piece here in terms of pressure in order to make sure that it doesn't jostle around or in any way impact the payload bay. But that's essentially kind of the build in terms of integration of the payload. The CubeSat is built out of aluminum and also steel. So the top and bottom pieces as well as side panels are aluminum, 1/16 aluminum, and then the steel corner pieces here are 1/8 steel.
Cool.
So for attachment into the rocket, as Vanessa already mentioned, it'll slide in, it'll rest against this bulkhead here, which
Yep.
again is the forward airframe bulkhead.
Yep.
Do you want to talk about that?
Yeah, and between when you have the CubeSat in there resting on the forward airframe bulkhead, well, another bulkhead, it's not quite ready yet, but it'll be fundamentally of the same form factor as the other bulkheads, same 3/8 inch aluminum with number 6 screws in there, essentially sandwiching it for a secure and tight fit.
And we'll have 2 separate rows of screws going into the sides to prevent any rotational loads. We did see in our flight dynamics analysis, or whatever you want to call it, from the past 2 flights that we had very minimal spin. So we're hoping that those loads are very minimal, but we want to make sure it doesn't start sliding around in there.
Cool.
We're also including the payload in the test launch on like this upcoming one on Saturday in order to verify that on like an actual test launch as well.
Yes.
Yeah.
Yeah, cool. Awesome. So you've got one more test launch coming up, I believe. Is that right?
Yes.
Yep.
This Saturday.
Cool.
This Saturday, yeah.
Nice. A little bit of work to do before then.
Certainly, yeah.
Yes. Cool. All right, let's just move on to just a couple more things to go over. Quick review of your of your testing. You're happy with I think the 3 things I wanted to talk about in your test results. Are you happy with your off-rail velocity? It did look stable on the video that I saw, so I don't think you got a huge problem there. I wouldn't be too worried, but I just want to make sure you're happy.
Yeah.
And
So
the deployment times of the separations occurred at the correct times.
yes, so for off-rail velocity, the first flight had an off-rail velocity of around, I think it was 66.5 feet per second, which was 3 feet per second higher than we simulated and admittedly quite low, but as you saw the video, it was stable off the pad. And our second test flight, which we completed, I believe 2 weeks ago now, had an off-rail velocity of 77.43 feet per second at departure of the first rail button. So that is exactly.
Your test motors are smaller than your competition motor. Is that correct?
Yes.
Yeah. Cool. Okay. Yeah. So I just wanted to confirm that. Yeah. Continue. Yeah.
Yeah. So we're very happy with that. That lines up very nicely with the simulations. That flight was, in fact, even straighter and more stable than the first one. And I'm not sure if you've gotten to see a video for that yet, but you can see we'll show you that in a little bit.
Yeah.
Next question was recovery deployment altitudes. Cisco, how did you feel about this?
I felt pretty solid on both of the flight tests. We deployed at 700 feet. They were relatively similar apogees of 3,000 and 5,000 respectively. I chose to lower the second flight to main deploy altitude because the cloud coverage was a little low.
Right.
But overall, I was happy with it. The second flight test, we didn't actually see how far the main went because it didn't actually fully fill the whole descent. But the first flight test, it only went about like 3/4 a mile or so.
Excellent.
So,
All right. Yeah. Cool. I'm happy with that. Cool. We can just get the last bit I wanted to cover is your preparation procedures and checklists. So in particular, what you're going to do for flight prep launchpad ops, scrub and recovery.
Sure, so we have our checklists. Fair warning, they are formatted to be more convenient to read at the launch site, so they don't.
Yep.
Super nice, but there's very big text.
I
I can
don't
share
need
those on my.
to set the detail. What I'm looking for is that you're comfortable that your procedures are enough. So if you just talk through that. Yeah.
Oh, so I can just talk through it instead of.
Yeah. I don't need to see it. I just want to make sure that you're comfortable with that. Yeah.
Sure thing. So we start off by getting the rocket more or less in this orientation. Make sure everything is present, make sure we're not missing any key components, especially things like quick links and harnesses and parachutes and all those connections.
Yep.
Then we start off on the mechanical side by integrating everything in the forward airframe. So we take the CubeSat, make sure the CubeSat is secure in its attachment mechanism, which right now is not fastened together, but will be obviously on the flight. We secure that in the airframe, check everything, attach the additional bulkhead on the top of the payload, make sure that's secure. Once we're confident that the payload is secure, we move on to the nose. Where did the nose cone go? Move on to the nose cone. We install the little nose cone GPS assembly over there, up inside here. It's not currently in there right now, but essentially, Nick, if you could bring that over, please. Show them the bottom. So ignore the
Nice little bag.
but we have two very nice arrows that say on, and we make sure both of those are on. And then we attach the nose cone in place.
Nice.
For the booster, there is very minimal hardware prep we need to do.
Yep.
Motor integration is essentially just checking that the motor mount tube is clean, free of debris, that the motor itself looks like it wasn't damaged during transport at all. That the adapters that we use, because we use an RA98 Aeropack, sorry, 98 to 75 adapter. We check that the adapter is on, the adapter is tightened, and then that everything fits in smoothly. We make sure we keep the protective end cap on the nozzle on, that nothing's damaged there. And then we just unscrew, spin on that ring, and we're all set with them. So for avionics based checklists, Daniel and Bodhi, did you want to talk about that for a bit? Yeah. Just for like how you guys prepare the app bay and get ready for integration.
Basically we before the day before we have everything already. Well, the day before the boards will already be on there, everything will be, and the batteries will be in place. Basically on site, we want to have set it up. So what we have to do is plug in the batteries here and then tape them shut and then close the av bay. Then what we're gonna do is put up charges in the charge wells and the raptors in there and attach them. And make sure they're all set. Put the igniters in first. I forgot about that. We attach the igniters first, and then we put those in. Put the charges in, and put the raptors in, and put the charges in, and then we close the. We check to make sure that all the recovery stuff is set. Like we make sure that all the quick links are tightened, and then we reef the line. Make sure check that the lines are reefed properly, and then we'll put the couplers together, and then we bring it to the launch rail. Do they free something?
Yeah. Once we're putting it together, once everything's assembled and the chargers are in place and the chutes are in the separate compartments, then you make sure everything's aligned, especially for the app bay. Make sure the shear pins go in easily, and you make sure there's no gaps between the sections, because we've seen this twice actually when integrating. We'll think it's all the way in, there'll be a little bit of a gap, and then it'll pop out. And that's just because chutes or harnesses were just not reefed or folded well enough. So we want to make sure it slides in all the way smoothly so that it comes out all the way smoothly, which it has both times. And then once that's all set, we have a full final review checklist for everything going from the booster all the way up to the nose cone to make sure everything's in place. All the peripherals over there are turned on, all the screws are where they need to be. We're not missing any shear pins. We're not missing anything important. The cameras are in place, the cameras are fastened, and everything looks good to go to the launch pad.
And then on the launch pad, we you want to do it?
Yeah. So once we're on the launch pad, make sure everything is again, still fully aligned. The shear pins are still intact, not broken during carrying for whatever reason. We lower the launch rail, put one rail button on, check the alignment, put the second rail button on, and then once everyone is ready, we move the rocket vertical. Then we find a ladder because none of us are tall enough to turn on the rocket otherwise.
Always made a
And-
ladder.
Yeah. No, and then we first turn on the cameras, then turn on the switches for the COTS and the SRED computers, listen for the beeps on those for continuity. Once that's all set, then we're good to install the igniter. Obviously check the leads to tap the leads together first, tap the clips together first, make sure there's no sparks. Then install the igniter, clear the pad, check continuity, and then ready for launch.
Right. With the computers, have you can you tell the difference between the particularly the COTS computers as you're switching them on?
Yeah, so we kind of just in the past two launches, they do make the same beeps, but we can tell that they're it's because they're timed to like 10 seconds apart. You can tell by the timing which one is which.
Yeah, cool. Okay. As long as you got a plan for
Different
determining
patterns.
the difference. Yeah, cool.
Yeah, so you can tell the difference just how far apart it is. For the COTS computers, we're gonna have them beep in different, or the COTS, the SRI computers can have them beep in different patterns.
Well,
Yeah, cool.
we'll actually have them beep in different frequencies so that you can actually differentiate between the sound.
We're probably gonna do a different pattern too anyway, but
Yeah.
Different time. Yeah.
tone in different patterns.
Yeah.
Yeah, and then on the pad, we'll check to make sure we get proper downlinks and stuff like that.
Yeah, cool. All right. I guess what's next on your pad prep?
Yeah, so once everyone is clear and back at the launch site, first thing we do, make sure, well, everyone's ready, everything's all set, there's no problems. We check that we have signal from the nose cone GPS, so the backup GPS system. We'll be checking once we finalize everything with the SRED computers and the telemetry, that we have a good telemetry connection and GPS lock from those. Then we run through the range is clear, sky is clear, weather is good, winds are low, and then just do a quick pull, making sure that the cameras are all set to record everything, that again, the GPS is locked, that nothing else has come up, and that everyone is all set to launch with specifically all the team lead, making sure everything's go. Make sure everyone's in position for recovery once the rocket goes up and comes down, and then we give the final call to the launch controller.
You might have missed a step.
Sorry.
He didn't cover the igniter.
Oh, we covered the igniter before we.
You do that.
Should be after the computers.
No, this was so I.
So I might have missed it on the as you were talking. We got into discussions about the audible beeps.
Oh, I thought I mentioned that before.
Yeah, no, just yeah.
Yeah, once the rocket's vertical, we arm all the flight computers, check for all the audible beeps, and then turn on the igniter. Place the igniter in. I'm sorry. No, I had mentioned it before and then I got caught up in the beats. Make sure all the recovery systems are armed first. Place the igniter in, check the leads, connect the leads, and then clear the pad and then check for continuity.
Yeah, cool. Okay. Perfect. Sorry, yeah, it sort of got a bit mumbled up there, so I just wanted to go over it again. Cool. Checklist for scrub.
Checklist for scrub. First, make sure the pads are cold. Make sure everyone is safe, nothing's happened to the rocket. Then we walk out, carefully check that nothing is still somehow smoking or on fire from a distance. Go up close to the rocket, remove the igniter leads, remove the spent igniter, continue listening for the beeps from the from the flight computers just to make sure everything's still armed, and then reinstall the new igniter based on the same procedures. If for some reason we don't hear beeps, then we need to make sure to turn the flight computers off while the rocket's still vertical, then lower the rail and take it apart and check what's happening.
Yeah, cool. All right, and recovery checklist.
Yes, so first thing is to make sure that everything is not on fire.
Yeah.
If it is on fire, we want to make sure everyone stays back. We'll bring a fire extinguisher with us and extinguish anything that's happening, but hopefully that doesn't happen. Has not happened yet. Shouldn't happen. And then we check that everything is present, that we're not missing any major pieces before we touch the rocket. Take a couple quick photos of the orientation, then check that the screws are accessible. If they are accessible, the switches for the flight computers, if they are accessible, we turn the flight computers off. If the switches are not accessible, then we cut the connection from the flight computer wires to the screw terminals on the bulkheads. You can't see it right now because they're already removed, just to make sure that the energetics are safe.
Okay.
Cisco, did I miss anything on that?
Sounds good.
Is there anything else you checked for? At that point?
At that point, then we start making sure that all the lines are connected. All the lines are connected, that everything is present again, and then we start folding things up. Once we have a chance to take apart the av bay and physically disconnect the batteries, we do that just to make sure everything's safe. Bodhi and Daniel, correct me if there's anything else we need in those checklists. But
do you have a step to check for undeployed charges?
Cisco?
Yes, so. After we've saved the flight computer. Check. The CO2 well, for the CO2 Raptor and the black powder wells.
Yeah.
Check for. Like. Undeployed charges.
Yeah, cool. Yeah, so as long as that's on the list, yeah. Cool. All right. I think that's it for everything I need to see. I'm just going over my checklist here. There's some specifics that I haven't covered. I might just quickly run over. Your team number and frequencies, are they marked on the outside of the rocket?
They are not. They will be before the competition. We're working on getting stickers from FedEx, right, Rachel?
Yeah, so FedEx has a weird.
Where will they go?
Where will they go?
Yeah. Where you playing?
Right here.
We
Yeah,
can
cool.
put them in multiple spots as well. It's just one. And they'll probably work in white.
I believe it's either white or black.
Yeah, then so we'll probably get a sticker in white and black and then put them on and see which one you can see the best. And based on whichever we see better, we'll put it on there. Based on regulations.
Cool. I think I did ask, but I just want to double check. On the eBay, looking at the vent holes. Just want to double check that.
4 vent holes. There's 2 right here. There's 2 right here.
I don't think I asked that. Sorry. Lucky I got a checklist.
Yep.
That looks good to me. I think that is pretty much it. Do you have any questions for me?
Let's see. Did you have any questions or concerns about the upgraded design that we were hoping to fly?
No, I'm comfortable. They're fairly minor changes. I think I've got revision F of your design of your open rocket. Has that been changed? Are you up to on your version?
So we have a revision G for this particular vehicle. Just because this booster has different weights than the planned booster, and that revision G currently has all the updated weights. Once we built everything, we measured it and put it back in. And we'll be coming up with a new revision once we finish building this one and update the weights on that. But
Okay,
currently, that's the plan.
would you mind sending through revision G now, and I'll just quickly review the new one once you're done. But I'm pretty comfortable with the changes. They're fairly minor in the overall design, I think. So there's no red flags there.
Yeah.
Cool. All right. All right, I think that's it for the review. It's a nice looking rocket. It's you kept things simple. It looks really good, and I can see from the test flights you should have a successful flight. Hopefully, fingers crossed. So looking forward to seeing it. Just the last bit of admin. Your recording needs to be uploaded to the. You need a downloadable file to the Ezra email address. So that can't be a YouTube or anything like that. It needs to be a downloadable file. The link, and I think that's it.
Lovely. Okay. Do you guys want to get in here for like a team photo at the end of the thing? Wait, and then I can just come around here and then we'll have the video from
Okay, I'm just gonna stop the video now.
Nice. Awesome. I need some audio on this side now.
our current one, and then I'll send you the version that we do for the upgraded booster as well.
Yeah, that'd be perfect. Yeah, thank you.
Sam, did you have any comments at all? Or?
No, I've been really happy with this in general. We had great test flight a couple weeks ago, and I think they've got it pretty well under control.
Yeah, it looks like it. Yeah, cool.
All right.
Awesome. Thanks, guys. I'll look forward to seeing the flight.
All right. Thanks, Fred.
Thank you.
Awesome.
Thank you.
Cheers,
Bye.
guys. See ya.